Well, good morning, everyone, and welcome to our session that we have aptly titled BTES at ACSA. My name is Franca Trujano, and I'm happy to say that we have a number of our speakers today that are members of the Building Technology Educators Society. We actually are really thrilled that ACSA continues to foster this relationship with BTES and offers us this session typically once every year at the National Conference, which allows us to discuss issues of building technology with the larger constituent group of ACSA, but also to kind of ponder questions that may be important to the membership or to a new membership. Today's session is different than what we do on an off year when BTES does not have its own national conference. Typically we would sponsor paper sessions for this BTES session. This year, because the BTES is having its own national conference in Utah, which we'll hear more about in a couple of minutes, we thought to take the opportunity to actually ask a question and to kind of ponder thoughts around issues of building technology that we may not necessarily always have the time to do when we're either busy teaching, identifying research streams, or even simply submitting papers to the BTES National Conference, which is a biannual conference. So today we've asked the question about how can we rethink the issue of how architecture and building technology offer us an opportunity to think through what we call our post-critical age. We'll bring up issues attendant to the polarities or the split that exists between how we think about theory and how we think about technology, how we operate on theory or ideas about architecture versus how we operate on the technology subject itself. And this is the kind of dialogue that we're hoping to have today. And this is only to be able to identify naturally that we expect that the next series of years will be an opportunity for us to find a shared terrain between how we do technology and how we do theory, if only to challenge the doing in both of those disciplines. So I'd like to introduce our panelists today. Terry Boak, who is from the University of Waterloo, Aaron Kerrer, who is from the University of Utah, James Dorfman from Philadelphia University, and Jonathan Massey from California College of Arts. Patricia Cooker is not sitting with us here, but she is going to be here in spirit. Unfortunately, she is arriving just a little bit later than the conclusion of this session, and there was a little bit of conflict in scheduling, but she has graciously offered us her text, and I will be reading Patricia's contribution, which I think is very important to the conversation. Now, I also want to point out that we actually have two past presidents from the BTES. Both Terry and Jim have been past presidents of the BTES. I'm president this year. Aaron is board member, and we hope to have new members or board members or new presidents from amongst our either panel or actually, in fact, the audience. Now, what is BTES? So the Building Technology Educators Society, I'm going to have to turn to Terry for this, was founded in what year? See, this is like poor institutional memory here from the current president.
Well, it started in the 1990s as there was a conference that was conducted at the University of Wisconsin-Milwaukee, and we didn't really get into, which was an offshoot of other conversations about technology and sustainability and environmental design, where there was a focus that was desired that was more structures and construction based. And then in 2006, we had quite a large conference in Maryland, which was run by Deb Oakley and Ryan Smith. And then from that, there was a decision made to form a society. And so it was a couple of years later that we got through all the legal documents in order to make ourselves into a nonprofit. So we're not even, I would say, 10 years old at this point.
And what I'm going to do is I'm actually going to creep over to the actual display here. And maybe I might ask someone to advance, only because I can't read the small presentation over there, nor can I read it from there. So just to give you a sense about what we do, we not only promote subjects attendant to how we teach building technology amongst our membership. It might also be difficult for you guys to read, I apologize. But we're also trying to always increase the question of critical discourse and scholarship around the issues of building technology. Through that process, we instigate a mentoring process that usually happens at our biannual conferences. so that faculty members who have achieved tenure and who have achieved success in scholarship can actually mentor younger faculty in this particular subject. We're always interested in identifying issues that concern technology relative to the larger accreditation process, which of course is why we're super interested to be part of the membership of ACSA, because we do believe, and I'm pretty sure many of us in the audience believe, that there is always an important discussion to be had about how building technology constitutes part of a curriculum for a professional architect. And we're also interested in thinking about how the building technology subject can help create relationships with the building industry. After all, technology is a component part of the industry that subtends the profession. To the extent that we can then facilitate relationships that are research-based is one of the mandates that our group is trying to promote in the next couple of years. So we hold a conference every 2 years. This year we are in Utah, and with that I might ask maybe Erin to say a little bit more, but just to identify that it's going to be at the end of June, between the 24th and the 27th. We, on a biannual basis, also have an Emerging Educator Award in Building Technology, and we have now inaugurating our first BTES Book Award. If any of you would like to have your work reviewed for this process, we would love to hear from you, and we've already had a really robust submission process this year. And I also want to have a shout out for a student scholarship. We are still receiving nominations for a student to be nominated as a sort of eminent person in the field of building technology, and I invite you to check out our website so that you can in fact potentially nominate one of your students for that scholarship. It allows the student to attend the conference and to be able to share their interests with a number of faculty members who are in this field. So I think nominations are for another couple of weeks still, April. So with this, I'll ask maybe Erin to say a little bit about the conference and the work that she's been doing with her group to organize the conference.
Sure. So the excuse me, the theme of the conference is intersections and adjacencies, leadership and architectural technology education. So we're looking at what even constitutes the field of building technology, and the definition of building technology beyond, as Terry mentioned, the initial kind of formation of the society was around structures and those sorts of things. And so we're looking at now design build and digital fabrication and broadening the definition a bit to look at the ways that building technology and all of its manifestations start to be integrated with other practices, with studio, with pedagogy, and all those sorts of things. So we have several tracks that are open, and I wasn't prepared to say a few words, but
that's great.
Yeah. So, and if you're interested, please let me know. We would love to see you in Salt Lake. It's beautiful in the summer, and yeah.
Yeah, great, and please join us. It would be awesome. Okay. So we do have a board of directors, naturally, with a series of positions and officials, such as secretary and treasurer. This is my pitch. Of course, you're sitting there. It's my pitch for the BTS. But it would be great to hear from anyone in the audience who has been interested in sort of addressing larger issues relative to the subject that they teach and trying to identify ways that they can engage fellow educators in this process. We do have large ambitions, or ambitions to be able to really sort of create a kind of context of importance for our field in how architecture defines itself in the next 10 years. And please feel free to contact any of our board members if that's of interest to you. All right, so we are in the process of trying to increase the kind of general sense of the scope of research for building technology, and for this we are founding a journal called TAD, Technology, Architecture, and Design. We hope to launch this year with our first call for papers. The editorial board is identified Marcy Smith from University of Illinois, Andrea Zorzinski from NJIT, Terry Boak from the University of Waterloo, and myself. And we hope to have a wide array of participation in the journal. The journal will have a series of tracks, very similar to the way in which Erin has described it. You know, at the beginning, when BTS was constituted, we thought that technology was in and of itself a subject. We realized that meeting our constituent groups and members, we realized that there are actual other sub-tracks of interest, whether it's structures, digital fabrication, so on and so forth. We want to highlight that and to make that part of the way in which the journal operates. So please look out for TAD. This is part of the journal mission statement. Clearly what we want to identify is the way in which all of these particular fields, whether it's emerging materials, construction techniques, design integration, structures, even the history and theory of technology, which is a little bit the kind of subtext of the conversation that we're going to have today. How does that impact the way in which we will be understanding the role of the architect in the future? All right, so today's panel discussion is actually focused on two simple questions. I'm going to have us focus here, and I hope this is big enough for most of us to understand. Or to read rather, so that I can help understand what are the main questions. We understand that many of the pressures that we feel in teaching building technology are related to the amount of technology that is out there for our students to apprehend, to comprehend, and to become experts in some way or another. Part of the question of today is, do we actually have a sufficient amount of work invested in how we encourage our students to think critically about those technologies, right? The onslaught of those technologies, of which I teach them all day long, how do we then, at the same time as encouraging them to become highly more professional and become experts in these technologies because it will help their practice bottom line, how do they apprehend also the kind of critical position to be able to gauge the value in the long term? That's one question. The other question, and maybe we can go to the next slide, the other question is, how does theory itself understand the role that technology can play and how it changes its own operations of thinking through what architecture means? It's a kind of a double sort of question. Can technology itself be more critical of its own operations? Can theory itself be more critical of understanding what the thinking process of architecture is if it doesn't begin to assimilate these kind of technological questions, which are basically profoundly changing the way in which the architect sees him or her practice? That's the question for today. With that, I'm going to offer the floor to Erin. I'd be more than happy to work on the slides. And so we have 5 positions today, and we'll have Erin's position first.
Sure. So I think what I really was interested in kind of addressing the questions that Franco put forward were thinking about, as a beginning design educator and also as somebody who teaches architectural technology, specifically digital technologies, really, how do we begin the discussion in terms of the introduction of technology? So building technology, digital technology, I think many of us are engaged in those conversations on a daily basis in our work. So, so kind of looking at it from the framework of Dewey, should be standing over there, sorry I can't read from here, but I won't read the quote to you, but kind of thinking about the pedagogical and the structural framework for this. So if you go to the next slide, and looking at it from the history of architectural curriculum and pedagogy. So beginning with the École des Beaux-Arts, looking at architecture as a fine art and the way that starts to get introduced. And using the framework of the analytique, right? So how do you start to begin to introduce exercises of kind of architectural representation and technology in that way? Then moving on to the Polytechnic, where architecture was taught fundamentally as a building science or a technical science, looking at learning all of the technical aspects of architecture before you move into the design phase. Next, some technical coursework. The Bauhaus, obviously we all know this history, but architecture as art and industry, so looking at the intersection between education and practice and industry and using beginning design then as kind of a fundamental aspect of the pedagogy. And so I think really the question, and maybe it's more of a question than a position at this point, if you go to the next slide. So I think the question is now, what is next? What is the kind of fundamental framework for this? And we're engaging in these discussions at my university, as I'm sure many of you are, about what is kind of the foundation for contemporary architectural practice, or foundation for contemporary architectural education. And so we're looking at a fully integrated curriculum where it starts to break down the kind of the silos of technology versus studio versus representation versus theory, and starting to look at this more integrated mix of all of the subject matters. And so I think it's less of an answer and more of a question at this point, and I believe that that's the kind of intention of the panel, is to pose a few thoughts and then have a discussion about it afterwards. So I think that for me, the question is about, where does technology begin? Where is it integrated? Where do you start to have these discussions so that you can build this critical framework for how technology, whether it's digital, building systems, structures, start to get integrated into the curriculum in a thoughtful way so that students can build that understanding and that critical awareness as they move throughout the curriculum.
Great. So with Erin's introduction to the meta question, Terry is actually going to walk us through a particular both analysis of the situation and a series of claims about how it could be addressed. And again, Terry, I'm not sure you're able to read that, but would you like to read that? Or?
I'll paraphrase it. There's a lot of things going on in practice and in architecture these days that, both from the point of view of education and what's happening in practice or lack thereof in certain parts of the world, that have begun to really put a lot of pressure on architecture and question how we go ahead with architecture. I think the manifestos and the statements that were made last evening before the wine and the cheese start to bring some of these questions in, but I think from a BTS point of view, which has focused a lot on technology, and in fact the entire organization, I would say, arose from a sense of isolation that a lot of technology educators feel inside of schools of architecture, where you're teaching those courses and then all the really important courses are over here. And I think some changes are in the offing that might actually reposition technology in a different way if the profession is going to survive. Next. So the three things that I really wanted to focus on was this new proposition by NCARB about licensure upon graduation, which I think it's intriguing, but it's also a little bit frightening, given the current pass rates for licensing exams, which are taken after people finish school and after they've worked in offices for a couple of years and grown up and matured and begun to balance design studio and history and theory with this vast array of technical requirements for buildings. And then the design intelligence survey regarding the schools with technical strengths, and even so much so as the students who graduate from schools that have no intention of going into practice. Next. And so, looking at the NCARB blog and this whole discussion that's really been in the forefront, I think, of thought for the last years, what do you need to know about licensure at graduation, and how does this actually go forward as a thing? Given that it's requiring a lot more technical coursework that would happen in school, the exams that would have to happen within the school, how do you actually facilitate that? Where does it fit in the curriculum? Waterloo, where I teach, is a school of architecture that's in one of the oldest co-op education schools in North America, and we have mandatory co-op education, so our students take essentially 2 full years of work experience within their 4-year BAS first pre-professional degree. So they end up with 8 academic terms and 6 co-op terms in that period. And so we would be really positioned well in order to take this on, but yet we're not jumping at it because we're seeing that there's potentially conflicts that would happen at school and that maybe this is best to happen after. Next. And a lot of this has to do, I think when you're thinking of what is the position of technology in the curriculum, and we look at the content and the direction of the exams and their pass rates, you can see that by and large the pass rates aren't stellar. Right now, if you look at the 2014 pass rates, are sort of averaging in and around the 65% pass rates, and that by and large the topics that people are being examined on are very technical. There's a little bit of history theory in there, sort of. When I wrote them, there was a trivia. I thought it was a trivia question exam, which was, do you remember, the quote by so-and-so and who said it, which is really, really minimalizing the role of history and theory in terms of the way these exams are. So I think that's a problem. Next. And then there was another big article that was put out in November 2013 that's still making the rounds, which was our Ivy League schools really offering the best architectural education, which was, it's meant to be a very contentious article, which I think it is. Next. because when they did the sort of survey of strengths, they found that there was a really clear divide in terms of the top-ranked schools, and they drilled down the qualifications. So communication, design, research, and theory, you see a lot of Ivy League schools, and then you see the construction methods and materials, sustainable design practices and principles, you see mostly other schools. Next. And so we've got this clear divide in terms of the responses and in terms of these design intelligence surveys that are really beginning to classify what schools have certain strengths. Next. And University of Southern California was the only school that actually fell into both categories. So we see schools that are very aspirational schools that have a certain nature to their curriculum, but that is clearly we have groups that are skewed one way and skewed the other way. So this licensure upon graduation could potentially be an issue. Next. And so this is sort of some excerpts from that particular article, but they're talking about, students that, what are the student opinions about what they're doing after school and where do they place their priorities? And there was, a real difference between the relationship between the schools that were those top-ranked schools and those that thought they would go on to practice. And so those that were in the sort of top box were less likely to be pursuing a practice-based career, and the ones sort of towards the bottom were more likely to be pursuing a practice-based career. And I would say that probably aligns fairly well with how they were educated to think about the role of architecture as a career and what kind of career that represented. And then, even though they say Harvard graduates are highly coveted by firms, they were the ones who were most likely to say, no, I don't want to work for somebody else, I want to be my own boss. Next. And so this is a little hard to read. This is from Black Spectacles, so it's a slightly skewed infographic because what they're selling through this website is continuing education on how to train people for software, like catching up on software. But what they're responding to is, and go to the next slide, blows up a little bit, you can see that the kind of skill that offices are looking the most for in a grad isn't licensure, it's lead. And so the top bar at the left is lead, and then going down into Revit and AutoCAD and the sort of more rote skills, and then way over at the bottom on the right would be things like Rhino, V-Ray, 3D modeling. So what the schools I see are doing in many cases in terms of digital technologies, a lot of schools are pushing digital design, which is embraced by the studio, which get beautiful renderings, and then the offices are actually wanting the other stuff. Next. And so again, this is going down to the LEED accreditation, again being the biggest thing that is being required by the offices in terms of a license. So they want LEED APs, and then the actual being getting your certificate in practice is much lower ranked. Next. And so really what I was trying to see is where does that position us? I mean, we can begin to leverage and say, well, if this is going to be a focus of going forward and coming out of a situation where schools aren't as highly valued, where we're not getting as many jobs, where the people at large are sort of questioning what is the role of architects in architecture, then I think the role of technology can have a bigger role to play in terms of education. But how do we position ourselves in light of this just data and general information and trends?
Good. Thank you, Terry. And we're going to actually have a position now that helps us see answers to this particular question, or vehicles towards finding answers to this particular question. Jim?
So my position that I'd like to present is about building technology playing a critical role in industry-sponsored research. So, what I've seen in the experience that I have is that the clients or sponsors that I work with have typically asked for outcomes. They've asked for new cutting-edge systems or technology that the students are able to do research on and speculate about what the next generation of technology might be. They're looking for highly sustainable, beyond LEED kind of criteria that might be added to their projects. And they're looking for efficiency. They're looking for bottom line sort of outcomes. Next, please. So what can we provide in academia that are solutions that can be part of these kinds of opportunities for industry-sponsored research to bring monies and support into our universities? So what I've seen and what has been an effective way of luring industry to schools has been the way that we approach projects. We can typically approach projects that are outside of typical industry constraints, and perhaps using the overused term of innovation or innovative in the way that we approach things. So we can provide very easily interdisciplinary teams, often creating truly transdisciplinary projects from the word go. We can provide research that is cost-effective, creating a value-added service for the client that would be way beyond their typical means or structure built around a particular project. And typically, we often have outcomes that surpass the expectations of the initial proposal that's part of the research. So the way that I've positioned places that I've been in has to begin modestly and begin your connections to industry in general. So beginning at Cal Poly when I was there, I provided a summer studio with 8 students that were in a studio situation in the summer. And I teamed with an award-winning regional practice, Rosling, Nakamura, Terada, and Bureau Happold. And with Bureau Happold on your team, you can almost do anything. And we did the Kaohsiung cruise ship terminal project over the course of a 10-week summer session. We literally worked in the offices of those 2 practices 1 day a week. We drove down to various practices. We had these full-day-long charrettes with the students. The students would go back, present material. We'd have, obviously, a bunch of different prototypes that we developed, and we provided an effective way of working. And the feedback from both the practice and from Bureau Happold was that they were very happy that we were able to produce a highly professional project. Next, please. Reaching out to other industry partners like Gensler, who we have strong connections with in the Los Angeles office. They're moving to a new office in downtown Los Angeles, and they asked us to do a desk for them in their main lobby as you enter in right off of the street. So I worked with 3 hand-picked students, and Bureau Happold was the structural engineer because we needed structure for this particular table, and a fabricator who worked for Boeing Airlines in Seattle to create a table in this lobby for Gensler. So there was a lot of constraints that were developed as we thought about the materiality of the project, the positioning of the project. There were some interesting client interactions because Gensler was our client, so we dealt with everyone from the project team working on renovation to the directors, national directors of the project, and we presented to them. And then there were issues of materiality as far as efficiency and being able to fabricate it. So we literally had the students follow it from initial design concept to using nesting programs for efficiency of the various materials, and then working with the fabricator when they said, we can't do that, trying to figure out what to do next. So that was quite an interesting project. Next, please. I then switched to develop a Master of Science in Architecture program at Cal Poly as well. And here I had the opportunity to have an ongoing graduate research studio. And I was very fortunate to have connections through alumni to various organizations that gave us reasonably substantial amounts of money in the $50,000 range for a semester, a quarter or two's worth of work. So one client was the Metropolitan Water District of Southern California. They were interested in creating a retreat center of their big reservoir facility in Southern California at Diamond Valley Lake. And so this upped the ante on what the technology and performance-based aspects of the project needed to be. The students not only had to design the individual units of the retreat center, but next please, they had to work on all the sustainability aspects, and because it was essentially an off-the-grid project, they had to understand water, energy, and waste for a complex of 100 units out in the middle of, well, almost in the middle of nowhere, but in central Southern California. So next, please. So these you can flip through. We can't pretend just flip. So you can see how we had to work through a systemic kind of approach. Oops. of the entire complex and literally work out a microgrid for this system of getting water, energy, and all these other components into the complex.
Check the connection. Sorry, I'm not starting to do this once.
Quick review.
Yes. Quickly taking notes. Flip through all.
Very gentle.
Keep going. You're good.
She's afraid.
She's afraid.
Okay, we're done.
Wait until you build it up.
This is the
Okay.
last one on the series, okay?
Yep, great.
Yes.
Also, in the Graduate Research Studio, we worked with ARUP through their ARUP Foundation and worked with a local Tanzanian charity to develop a Same Polytechnic in Tanzania, which became a training facility to give people skills for various things from auto repair to working in the hotel industry because they're very close to the Kenyan border and the mountainous area there that caters to a lot of tourists. So again, the issues were not just of the building and aesthetics and the general sort of master planning, but had a lot to do with the technicalities of building on this particular site. We developed a very intense water usage strategy with ARUP, and we spent, again, quite a bit of time in their offices. This is the working session where we literally pinned up all of the material on a conference room wall in ARUP and went through it item by item with engineers from ARUP's office that would come in and out as needed. So the students that I have for these types of projects actually varied. They were in an MS program, so I had some architects, but I also had construction managers and people with other kinds of general skills from the built environment area. So it truly became a transdisciplinary project from day one, everyone bringing their skills to the table. Next, please. This was a desalination plant for Monterey, California, which is currently being built. California American Water, which is American Water is a national water treatment corporation that has small water districts in various states in the entire country. They approached us and they said, we have a very tricky project. We are forced to create a desalination plant through federal law, and we have to make sure that the city of Monterey is on our side when we develop this project. So we would like you as an academic agency with students to develop the initial strategies for how we develop this project. So through the 20 weeks of working on this project, we not only had to take the engineer's original schematic design and change it to create a more efficient strategy, but also do multiple presentations in public forums with mayors, local stakeholders, local environmental agencies that became very tricky at some points, and basically sort of help California American Water make this a palatable solution for a required desalination plant in Monterey. Next, please. So again, the outcomes had to be very specific and very measurable to some degree. We really only provided a schematic design. And next, please. And our document went out to the design build firms, the large engineering design build firms, to actually build the desal plant. And we had to show efficiencies between the original schematic design by the engineers and what came out of our study. So as you can see here, we see a chart talking about cut and fill from the original site and the original design, and all the various things that we were able to create efficiencies on. Moving to Philadelphia University now, where we're pretty well connected with the local community and developing a consistent series of projects throughout the school year that envelops the more than 20 design disciplines we have at the university. We have a Nexus Sprint project track where various institutions can come to us and talk about doing short-term, long weekend, 2-week-long type projects. And we were asked by a large media corporation to come in and do a house of the future for 2020. They didn't want the design for the house, they wanted thoughts about how people would interface with the various technology that needed to be in the house in the near future. Next, please. So some students had this idea of creating a ghost project where you'd have something that would follow you around, essentially being a truly interactive floating phone, and allowing you to connect with the technology that was being provided by this large global media company. This was 90 students, 15 teams, interdisciplinary across our college and 2 other colleges, and we did it in 1 week, and the students had never done a movie before. And they created these wonderful 3 to 5 minute movies that blew the media company socks off. So next please. So when a sponsor sees data that supports decision-making around concepts of efficiency, sustainability, or a better bottom line, there's greater belief in the support of the outcome. Can the way we teach design and technology create leadership through technological research? Is my question as to all of this.
Thank you, Jim. Thank you so much. Great. So with that, I will read. Would you want to speak to this last slide, Jim? Okay. So with that, I would like Jonathan Massey. I don't know, Jonathan, if you want to...
Yeah, do you mind?
Not at all.
I
can do it.
Oh, you can do it. Okay.
I can do it.
All right.
Good.
Hello, team. I am not a building technology educator, I should say. I've never taught building technology. I barely studied building technology. But I'm glad to be here to learn and to share a few thoughts that I do have from the little bit that I do know about building technology. Next. So I'm going to expand on one thing that I touched on last night. My involvement, I'm mostly active as a historian and kind of critical thinker about architecture. Even though I did train with an MArch and practice a little bit in LA after my graduate degree. But recently I published this article on the Gherkin that engaged me for the first time in really trying to wrestle with a technologically sophisticated contemporary building from more than a kind of glancing engagement. And what I was really interested in was trying to figure out what kind of political and economic work the Fleury St. Mary Axe performed. And that led me to really scrutinize its claims about sustainability and to understand that the claims that Foster and the design, in a sense, made about environmental performance were linked to trying to help the City of London manage some of its other risks. So managing climate risk was the kind of way that this building was pitched to us. And I concluded that it doesn't do that at all, except in as much as it manages our perception of climate risk. So then I was very interested in its relationship to counterterrorism and the way it also kind of gained credibility and kind of operated on how the city managed perceptions of terrorism risk. And then finally, I started to feel that the main agenda of this building was to help the city manage the risk of losing financial services industry to competing centers as far away as Frankfurt and Paris or as near as Canary Wharf, and that managing globalization and its risks and opportunities was probably the strongest agenda. One of the things that I was really interested to learn is I started to understand that, among other things, the building also shored up or kind of emerged from a network of specialized consultancies, many of them in and around London, who specialize in, we think of Permis de Lisa, for instance, or Front in New York, or, there are so many different specializations that I think you guys understand much better than I do, that it takes to build a building like the Gherkin. And a geographer in London made these social network analysis diagrams, and this is another version of them, to understand how the new kind of branded skyscrapers in the City of London were part of an ecosystem of expertise. much of which resided in London, and that this was actually an economic sector of the city that the building boom tapped and reinforced. And so not only did the building kind of help the city maintain its preeminence as a center for insurance and other financial services, but it also supported this whole other industry that I really hadn't thought much about before. And so this guy, Ollie Mold, the geographer, also mapped some of the firms that were involved in that cluster of high buildings to sort of understand this spatial dimension of the economy of expertise that a sophisticated diagram structure like the ones Terry writes about, that it takes to get them built. So that interested me in this question of how, and I think I'm very late to this conversation compared to you guys probably, the question of how a design process or an architectural proposition rebuilds the society and the economy around it. That our choices about materials, construction methods, detailing, and the building process involve often globally sourced supply chains, but they also involve local labor pools. And one of the ways we can think about building technology, and again, I'm embarrassed even to say this because it's something that I think many of you probably understand better than I do, that we're, in our choices about building technology, we're also promoting visions of the kind of society we live in terms of those material flows and pools of expertise and labor. So I've been thinking about this in relation to the Creative Architecture Machine Studio at CCA that I alluded to last night. So this has been eye-opening for me. My relationship with the teaching of building technology has mostly just been make sure you meet the comprehensive design, integrative building design requirements of the NAB accreditation. That's something I work on with my colleague Mark Donahue in the back row, who chairs our Bachelor of Architecture program at CCA. But this studio really opened my eyes to a different vision of building technology, coming largely out of the tech sector and Silicon Valley, and the maker movement, and a kind of DIY hacker approach to building technology. We are invested a little bit in robotics, and we do a lot of prototyping and CNC milling and stuff like that. But we don't have the big robots that the GSD or Michigan or SciArc have. We're more of a scrappy, independent art and design college. And so the ethos is more about what can you do with $160 in stuff from Radio Shack and Home Depot, duct tape, plastic, things, little Arduino controllers, but light on the really expensive techno products. And so students learn to prototype things in a way that our colleagues in industrial design and in interaction design often do. And so they work in a really different way. And they're not so much designing form as imagining a new way of going from design through construction. And this hexapod, robot that's supposed to walk around squirting out some kind of 3D printing material is a nice example. I didn't try to embed a video because I was sure that would go wrong, but the final review is a demonstration that your prototype works. It's a proof of concept, and so the hexapod robot has to scuttle around squirting in order for the students to have succeeded. It's a really different pedagogy than I had experienced, and I really like the way this thing is supposed to go around bioremediating contaminated sites by sensing where the pollutants are and then injecting the green magic liquid into the soil. What I really like about it is that it engages students in working as technologists in order to rethink what even architecture is or what is the role of an architect. And they're learning a little bit maybe from the business model of Silicon Valley as well as some of its ways of working. And so just a couple more images. Here's another, this is an underwater 3D printer that, don't ask me, but it was really cool to watch. Next, and this one I think was everyone's favorite. This is a little sort of swarm of robotic bulldozery things that the students used sawdust, which was readily available to them in vast quantities from the wood shop, to simulate, let's say, sand or dirt, and imagine this thing going on, this swarm that they unleash on a territory, which senses and algorithms, and then it builds up these igloo things out of whatever the readily available materials are. Anyway, so, and then they share their work. There's a kind of open sourcing ethos, and so they share their work on instructables.com, which is part of the Autodesk empire, and teach and learn from one another. And so, as I suggested last night, I would really like, I'm really inspired by that as a pedagogical experience. It activates the students in a very different way than most of our studios do. But I also think one studio isn't going to do everything. And then one of the set of questions that they don't address in that studio is who builds the robots, who's unemployed because of the robots, what are the social ramifications of these scenarios that they're prototyping. And so I really would like to put that innovative work in dialogue with groups in our field who are raising those questions about how we build. And so who builds your architecture, which is led by a few different people, including Kanambari Bakshi and Mabel Wilson, is one venue for challenging us to link questions of design with the politics and social justice questions about construction and technology. And so they ask questions about labor camps in Dubai and the extensive employment of migrant and undocumented workers in building construction afar and at home. I participated in November in this great conference at Newcastle called Industries of Architecture, where I learned a whole bunch of ways to think about this. And I think the website has the book of abstracts, which I think would be really interesting to people in this field. It taught me a whole new way of thinking about architecture as a creative industry linked to other fields of knowledge and work, from laborers on the building site to engineers to specialized consultants. That was pretty cool, and that's where I learned about the writings of Sergio Ferro, a Brazilian architect and painter who, from a super jargony Marxist point of view, that really challenges architects to partner with construction workers and builders and learn how to design to the capacities of our partners in construction. And it challenged me to think in a really different way about how technological expertise, especially around construction, and he means the actual workers on the site, that we can partner with them. The conference expanded that framework to think also just about all the associated professions that we work with. Peggy Deemer gave a keynote about the capacity she sees in BIM for the architect to partner in different ways with adjacent fields of expertise. And so the last thing I wanted to highlight is the work that Peggy and others are doing via the Architecture Lobby, another kind of activist group that has gained momentum in the last year or two, to rethink our own labor conditions and practices as architects, but also how our work promotes the well-being of people in other parts of the building world. So those are my thoughts about building technology and education.
Excellent. Thank you so much, Jonathan. So my intuition to ask Jonathan to speak on this panel today was in fact first identified by sharing some of that time at the Industries of Architecture, which I would also recommend if there are any of us in the audience that are interested in this kind of larger social, environmental, and economic set of questions that are attendant to building technology and architecture. I think it is a great source to see where some of the scholarship is heading right now in that area. So thank you, Jonathan. So with this, I'm going to now not become myself. I'm actually going to speak for Patricia Cooker, okay, who unfortunately, like I said, was very excited about the session today, but unfortunately the scheduling didn't work out. So she has sent us her presentation and has asked me to read it for her. So I'm going to now alter myself into Patricia. So her thesis is that the advent of 21st century technologies, coupled with the irreversible consequences of global climate change and the shifting urban needs for an expanding urban population of 2.5 billion people, delimit the core challenges that are defining the future of the discipline of architecture. Her short paper is going to overview the STEM Academy's charter and promote architecture's evolution into a STEM discipline. So as early as 1857, with the founding of the AIA, a wish to promote the scientific and practical perfection of architecture existed, and those are the words from the AIA. While the Paris School of the École des Beaux-Arts cast its shadow, a shadow over all of us, a wholly American initiative of scientific construction grew from Chicago. In a programmatic statement of 1939 called, quote, Training the Architect, Walter Gropius proposed that the architect's role as a coordinator and integrator would be about, quote, all social and formal and technical problems of our time into organic relationships. The aim was to solve that, end quote. For Gropius, the architect's role in modern society required a complete reorganization of education, beginning in kindergarten play and developing a student's aptitude for building technology and profession. For Gropius, all architects must be trained in construction workshops on the building site, rather than change to the, quote, bloodless drawing board and the this is a good one, the phantoms of tradition, end quote. Today, many students enroll in architecture school with a commitment to artistry and the admiration of the formal bravado of star architects. Admission standards to architecture programs are some of the highest across the university, and yet as graduates from an education system that values the correct answer, young architecture students struggle to come to terms with the process of problem solving through design. The American system of primary and secondary education is currently reevaluating its pedagogical structures. The complex demands of our global future require a workforce, this is an interesting sort of correspondence, a workforce that are highly educated, yet are flexible and collaborative problem solvers that work across multiple disciplines. STEM education is now defined as meta-discipline and is the creation of a discipline based on the integration of other disciplinary knowledge into a new whole. STEM education proposes to offer students unique opportunities to make sense of the world holistically in an integrative manner rather than with the knowledge in discrete silos. This is one of the questions that Erin posed at the very beginning. The pedagogy for STEM emphasizes creative thinking and broad acceptance of differences and cross-collaboration while de-emphasizing rote learning. The national science standards that supports STEM education underscore less emphasis on verifying science content and more emphasis on activities that investigate and analyze science questions. Thematic, problem-based opportunities paired with meaningful communication of understanding, explored through questioning and conjecture, developed through reflective analysis and inquiry, is not a new idea. This is the core studio pedagogy for architecture and all of the design disciplines. Design models may differ widely, but all models consistently identify similar activities. That is, how you identify a problem, how you define it, how you think through ideas, how you evaluate, and how you iterate. 21st century design thinking blurs the analytical thinking in this process by including intuitive and emphatic modes to integrative thinking. Design thinking then becomes human-centered, collaborative, and a multidisciplinary problem-solving enterprise. The greatest hurdle for the STEM Academy is in assimilating these design pedagogies and the construction of a learning environment in which students can work collaboratively and take charge of their own learning. The irreversible consequences of global climate change, which is a result in large part to the building and construction industry, and the shifting needs for an expanding urban population of 2.5 billion people demand holistic and innovative solutions. There are unprecedented environmental, technical, and performance issues for buildings, spaces, surfaces, and materials. By the year 2035, approximately 3/4 or 75% of the built environment in the United States will be either new or renovated. A transformation of this magnitude, with implications for the building industry and for the environment, represents a historic opportunity for the architecture and building community. Our success will rely on the development of high-performing buildings, new technologies, and emerging partnerships that will redefine the profession of architecture. To be relevant as a professional discipline that continues to act in the public's interest, architectural education must embrace the expanding agenda for the science of building technologies, incorporate new modes of visualization and data collection, and situate building science and technology as core elements of the design curriculum. We must strengthen both the curriculum we use to educate the next generation of architects and the training and experience necessary to better intern architects for licensure and the technical rigors of a future practice. Further, architecture education should acknowledge its genetic DNA in STEM initiatives and should envision a curriculum with the capacity to attract the future high school population of STEM-educated students. This thinking requires recasting the epistemology of architectural design in relation to the domains it intersects, including science, technology, engineering, and math. How well and how imaginatively schools will rise to meet, incorporate, and identify with STEM initiatives, and evolve an architectural education to meet the challenging demands of our future is the most pressing question for architecture educators today. That is Patricia Booker's contribution to the conversation. So we thank Patricia. You'll thank her later when you see her. Great. Okay, so that was quite, check the time here. That was quite a delivery of 55 minutes. And we've had physicians that have been asking the most broadest of questions regarding our short history in the last 200 years. We've looked at sort of thematic problems that come from the way in which our students exercise through education, licensing, and what in fact the practice is requesting of us to deliver, which is a whole other topic all into itself. We've looked at actually very sort of positive opportunities to integrate our students into these activities for which their value is directly acknowledged and in fact often with financial recompense, and why not offer that as an opportunity for our students, as Jen has identified. And then we've looked at some pretty essential questions of critique of the value of technology if we look at social, if we look at branding, if we look at economic and environmental issues. To what extent does the representation of this technology actually live up to its mandate to change society, when in fact we realize that we have an incredible number of demands, whether they are demands of materials, labor, or energy, that we need to acknowledge. And then we see the extent to which Patricia is actually offering us a kind of meta way to think that potentially part of architecture's core mission is in science, technology, engineering, mathematics. So with that, I wonder if we might entertain actually questions from the audience and actually open up this for a conversation, because essentially we just offer these as ways to generate ways for us to think through either issues of policy, issues of how we teach, issues of how we engage the next generation, and actually really critically how we encourage, of course, our young constituent group, which are our students, to see not only their transition into practice as being a successful one, but one that empowers them given all the demands that we've heard about this morning. So I'd be more than happy to kind of open it up to questions and maybe back and forth. I don't know if the actual presenters may have some questions of each other's work. Maybe that might be one place to start. Jonathan or Rashida.
Well, thank you all for your presentation. So it was really great to see the kind of range of inquiry around building technology. Jonathan, I wanted to ask you about your Creative Architecture Machine Studio. Could you give some background on where that's situated within your curriculum? I think the proposition that it might begin to answer some of those social questions about social and economic questions about building are really interesting. but I'm wondering how it fits into the context of your work. And as a follow-up, I also think that it's potentially something that's really fundable in the same way that Jim has been successful with the studios and Cal Poly and now at Philly. So
Yeah. Well, it's my job to try to help fund it, so I'm working on it. It's an advanced elective studio, and so students take it after they have completed all of the accreditation requirements that pertain to technology and design. But I've asked, I'm working with Natalie Gattegno, who chairs our graduate programs, to try to expand the pipeline, because right now it's one studio that we offer once a year. It attracts huge audiences and from well beyond architecture to the final presentations. We work a lot with Autodesk. They have sponsored other studios of ours, and so we have connections to the local tech community through them, but there's some bigger fish in the tech sector that I think that work engages. But so Natalie and I are trying to figure out how we can expand access to this way of working. And I actually think it would be great, and Mark and I have also talked about the undergraduate program. CCA has a foundation year, much like RISD or some other kind of art and design schools. And I would like to have courses like this. It's so multidisciplinary, and it doesn't require, you don't have to be expert in architectural design or painting or any of our disciplines to do that kind of work. And so I'd like to put it at the very beginning of some of our curricula too, and see if it can ripple through the ways we do other studios and other courses.
A large number of you guys, including Patricia, who's not here, mentioned the desire to kind of look at a more interdisciplinary thing, especially with engineers. I'm actually an engineer by training. And in our programs, we don't have the same ability as within the studios to kind of interact. I was wondering if you guys have any ideas about how you could do something to get the future engineers who are going to be working alongside our architecture students to design buildings, and how to actually engage them in a context that they can get, if any of you guys have had any success with that.
The perspective I have coming from Cal Poly and now Philadelphia University is that we have an engineering program in both those places, and we were quite fortunate at Cal Poly that we had architectural engineering that was based on structures. We also had the support of that curriculum and the faculty in that program to clear out enough space in the curriculum so that they could take an architectural class or studio. So they were taught in their foundation year together with the architects, and then they had to go through their very strict ADEC accreditation process in the curriculum, but then it opened up to have an elective option later on. So that's where we cross-pollinated with either a studio or an elective in some fashion, and we're able to get that kind of thing happening. What we're doing at Philadelphia University is working with our capstone project in both disciplines, where we can create an interdisciplinary studio and support the engineers to actually come in and work on an interdisciplinary project.
Also from San Luis Obispo, Claire Olson with Sinead McNamara from Syracuse University, who's an engineer and teaches Syracuse's engineering courses. They taught together a course that mixed engineering students and architecture students together. It was funded by the NSF as part of a pedagogy grant for engineering schools to try to test ways to put the creative model of the design studio into engineering pedagogy. And I think they reported out on that to NSF, and they also are about to publish, or maybe it's out now, is it out? They've published a book on collaborations between architects and engineers that reflected their engagement with professionals in practice based on what they had learned in the studio through the NSF program.
I'm Jeff Tillman from the University of Cincinnati, and I will not play Patricia Cooker, but this is probably what she would say. We've also addressed this question, and we have implemented a Ascend program, we call it, a partnership with our College of Engineering and Applied Science, in which structural engineering students now take 2 architecture studios in their third and fourth year as part of their ABET accredited program. So they take our history, they take 2 studios, they do our graphics courses, and as part of their regular curriculum in structural engineering. And then those who wish can choose to then enter our MR program with advanced standing. We've also created a cross-pollinated capstone situation where the 5th year, which would be 4th year in most programs because it's a co-op thing, the 5th year graduating structural engineering students do their capstone by engineering a 4th year or 1st year graduate architecture students project from the term before. And so they work with the designer, learn what the values the designer were putting into their design, and then they work out the engineering for the project. It'd be great if there were more synchronicity, if the architects, unfortunately the architects go on co-op at the moment that the engineers are doing the engineering, and we can't seem to get everybody into the same building at the same time. But overall, it's worked really well because it's, the engineering students actually have a designer to talk to and to learn from, and you get a variety of projects. So we're trying to make these cross-pollinizations work, and in our particular context, it's a little different because they're in 2 different colleges, unlike Cal Poly where they're all in the same college and everyone's paid by the same guy. Our problem is that we have to account for every moment they're in a different context because that's how you get paid to teach these students.
And I'm hearing this is basically a structural architectural conversation that's happening. It's not really getting, I'm just with the move towards more sustainability. Mechanical engineers in a lot of Canadian schools don't get a lot of that. We're
actually hiring a pod or cluster of 6 engineers and architects to start a sustainability credential program, and so of these, 4 will live in the College of Engineering, 2 will live in the College of Architecture, Design, Architecture, Art, and Planning. And so 3 of those folks are being hired right now. And the whole intention is to really create a core of research and teachers who will break down some of these disciplinary boundaries and teach a truly interdisciplinary credential, at first a certificate and then a degree in sustainable environmental design, I think is what we'll be calling it.
Great examples. Thank you so much. I think, Julian, you had some comments?
Yeah,
questions?
Thanks for the presentations, and I'd like to, if you don't mind, to try to bridge a couple of things and perhaps open up a kind of a question later. But I mean, I've been trained, when I studied architecture in Argentina, so we were licensed immediately. We finished, just that's it. You can practice, you can build a building. So it's kind of a different model in terms of the kind of pedagogical questions that you're being asked or being developed. But there's also sort of an aspiration, which is basically, there's a model that relates the sense of what you learn is applied directly to what you're going to be doing, immediately when you graduate. That's one question that connects to what Terry was talking about. How can we begin to imagine kind of the new model for that purpose? But I'd like to point to a couple of things that connect to what Jonathan was talking about, sort of with your title, Building Together. It's a very powerful idea. It's a very powerful idea at many levels. One is that in a certain way instills in our young colleagues, as I always like to call them, the desire to see things built. And and I think the cases that you mentioned before, your examples were also connected to that. So this is instilling in students both the kind of the questions that come from this desire to see things done is extremely important, because we do not know how profession and practice would be in 10, 20, or 30 years. So what we can do as educators is connect that desire almost like a very, very forceful way that is kind of the gut desire to see things done. But that, I think, connects also to a question of risk that Jonathan, you mentioned in your studies of the Gherkin. But I would like to just simply put it in two different ways. One is that if we were able to envision a different delivery model for buildings, then it's possible that the construction documents that need to be produced to build something, which is a stack that connects to insurance issues of drawings, it's what I call the defensive model of delivery, could become different if the engagement with the construction processes is stronger. And that starts from that desire. I think, Franca, you mentioned that at the beginning in a certain way as a question. And I think this is a very important discussion to be had in all our schools.
Do you have any observations?
I would concur with that, and something that Jonathan said about, the building of things and sort of the morality of building things. And I think that a lot of what's missing, and it brings in interdisciplinarity and sort of collaborative learning, and Jim's idea of bringing in real world projects and taking them out of the sort of what I think is the bubble that's in a lot of institutions, that this is all in a digital realm, and bringing them to the realities of building things, whether it's through prototyping or even on the construction side. I took a student of mine who was doing a master's studio at Tsinghua University in Beijing, and I had an opportunity to tour a diary building that was under construction. It was by SOM's office over there. And she was in her master's, and I'm taking her to the site, and she was just like a kid in a candy shop. She'd never been on a construction site before, and it was just the learning that you look at when you see actual people making these buildings and these artifacts. I think there's so much richness that's missing right now in a lot of education, because it's trapped in this really wonderful, seductive set of images that's, I think somehow we've got to get to the next level.
Yeah, and I think
Yes.
just to
Go ahead, Erin, and then we'll, yes. go ahead.
well, I'm just going to follow up, and we've done a lot of research on collaboration, kind of back to the point of the relationship between architects and engineers. I think there are a lot of really innovative firms that are exploring new models for practice in terms of being more collaborative. They're few and far between because of the risk issue that you talked about. But I think that the most successful projects and the most successful delivery of projects happens in these new kind of collaborative structures, whether it's integrated project delivery or something along those lines. And they're using technology as the kind of fulcrum for it to work, but it's really about the interpersonal and collaborative relationships that are so important. And so, we're bringing that into the curriculum through collaborative, through industry partners, through these really direct hands-on engagements in the first year. And so the idea of that starting in the very beginning kind of fosters that. And I'm really interested in the idea of the kind of maker studio in the beginning, because it's really about engaging students and getting them excited about those sorts of things, and bringing in other disciplines and clients for beginning students to really look at the structure. So we're not trying to educate, digital fabricators or contractors, but we want people to come in, the students to come in, professionals to come in and share that expertise, so that the students, the architecture students, start to understand how they can engage collaboratively with other professions and disciplines from the very beginning, rather than having that mentality of the genius architect that's going to make these beautiful designs and then everybody else is going to figure out how to build them.
Yeah, I guess my question is sort of, I may not even live here. I guess my question is this question appropriate for the forum, but there's a lot of discussions around project delivery, which is great, I think. But I think another issue in the discipline, at least in North American practice, is procurement, like issues around project procurement and what the mandates are around that, and where, I think that goes a lot to our sense of agency as deliverers of a project. And I guess my question is, is there a role that we want to try and assume as advocates around notions of delivery, or procurement in North America, because if we compare it to other, national models where, there's a more limited context that we're working in. I mean, for a sense that emerging from school with a degree and being able to, compete in a public bid process for the large institutional project is an opportunity afforded to graduates in other countries, not an opportunity afforded to graduates of North American colleges. And so I think there's an anxiety around our discipline in this, context that may not be organic to other contexts. And so I just wonder, is that a conversation that's, something we want to engage in?
So just before we let that thought go by, can I ask you a question just so that maybe, so is the anxiety, do you think, a function of the risk factor that is a component, or do you have ideas about where this anxiety is coming from?
Well, I guess my thought is the anxiety is around a lack of expressed confidence by the market that we're working in, right? That a civic government is not requiring architectural design for certain kinds of projects. Likewise, when they do put things up for RFPs, there's a set of requirements that are forced to be met by practices that there's basically like young practitioners have to go through designing small pagodas or podium for the local government for 5 or 6 years before they even get to bid on a public housing project. So it's just a very different. And so I'm finding in academia we're really focused on this kind of small scale, but whatever.
Well, so the question to Jim, the water salination plan. I mean, the idea that the students would come in, you said actually edit the original engineering concept for it, and then that would have an incredible amount of buy-in in local government to know that Cal Poly students worked on that project, right?
We did. And what made them confident was the data that we produced, the savings in cut and fill, the feet of pipe that we cut out of the design. In addition to sort of the siting of the project in general and viewpoints and all those sorts of issues. But I think it's a procurement is an issue that not only that we have to deal with in the academy, but we also have to deal with it in industry. Some of the conversation around IDP and the positions that were presented yesterday evening, and the idea of actually getting a job isn't just about individual architects getting a job on a practice, but I think it's about architecture and the way we present ourselves to the public in general. And the confidence and risk factors that we have to overcome with many people that are out there that are not sure if our services are worthwhile.
Yeah.
Well, please respond and we'll move on to Don. Yeah?
Oh, I'm sorry. No, and I guess my question is not only just representation or presentation of ourselves, but actual advocacy and advocacy at the governmental level. And how do we, is it possible for us to initiate some kind of shift? I don't know. It's just a question.
Don.
I very much appreciate what all of you have said about this exciting panel to listen to. I have a question in another direction that might be a little off the panel's topic, but I don't think off our topic together. If you talk about this STEM, and some have proposed it should be STEAM or something like that, and I believe that there's other kinds of positions. But if you look what's happening, and we all know it, what's happening in the public schools and the budgets and so forth, it's the art programs that are cut. If they cut a program, they cut art or music. And so we have young people applying to school. It gets more and more difficult. What does society value? Do they value the STEM, the NSF grants, the big sheet comes, that's driven ideas. I wonder to what extent, because this last question is also, I think, about that a civic entity doesn't think that an architect can bring something to the table that has some kind of depth, but also represents this other realm that is the A. And how to, it may be that we need to start much earlier. You were speaking about Corpus and how
Patricia.
Patricia.
So do I, right? Okay, so that's conflict, but absolutely, yes, Corpus.
I'm not advocating that program. But what you start to see, there are students that participate in, of course, Odyssey of the Mind program. I wonder to what extent we should, and we all have busy lives, we should be interested in this. Because what happens, students come to the university and they're programmed already to be STEM people or in that direction. And then architecture and art is an add-on. It's an adjunct to this other, okay, we have so much. And the percent program for art, it has helped to some extent, but did it really? The artists have moved ahead and gone around that class. Ollenberg himself said, what am I doing? Putting my sculptures in civic plazas there is degrading my work. Artists have moved around to make projects that are actually engaging the scope and needing engineers to come in and engineer their large-scale things. Getting civic entities to agree to have a Christo. I mean, Christo is a very clear one, making a project and just doggedly pushing it through to them. So I'd like to hear
one place where high school kids are making architecture is Minecraft. I've been talking with people in game design at CCA. We have a program in game design that we're forming, and we have people who already teach courses there. I've been talking with them about how can we show gamers that part of what they like about Minecraft or whatever world they're inhabiting or building, part of what they like about it is that they're engaging architecturally, and they're either creating or they're negotiating with a kind of virtual built environment. Of course, from a recruiting point of view, because as an art school, we face exactly that challenge that you're talking about. But I feel like part of it is trying to find where the passions that might be manifest in architecture, where they're being expressed currently. And for me, I'm not a gamer, but my sense is that there's a lot of potential there.
It's really interesting. It was eye-opening to me. I joined 2 or 3 years ago a board, a building technology advisory board for all of the state high schools. And it's been really interesting as one of the only architects on that board to understand the disconnect that we see between what's happening in high school and the types of building technology classes that they're teaching that are basically, this is how you use Revit. And what we really would like for people in the kind of foundational education for our program to have, which is more of the design thinking kind of aspects of creative problem solving, hands-on engagement, those sorts of things. And it's interesting because the guidance counselors don't know what architecture is. They never advocate for students that show propensity towards art and science and math and this kind of making. They don't even think about architecture. They send kids that are creative to gaming, they send them to graphic design, or they send them to engineering. And so I think it's partially a awareness of what it is, what our value is. I mean, we have to make a case for it. We can't just assume that somebody's going to value our skills because we value them. And I don't know, it's a really big systemic question. I think one of the things that we're doing is trying to work within the system. So we have one of our professional organizations has a program that goes into elementary schools and uses the standards of learning to deliver architecture education for 5th and 6th grade students for 8 weeks that covers a series of learning objectives that the teachers will buy into. And so it embeds architectural education, architecture design and planning education into this program while they're getting whatever math and whatever credits they get for things that they check off the list. And so that's one of the ways that we're trying to do that. But it's really, I think it's about expanding the conversation beyond just the architecture education to the larger STEM or STEAM that you're talking about.
I wanted to pull in the idea of gaming a little bit more because I think there's a lot to be gained with gaming, whether it was The Sims. My kids all played The Sims before, the youngest one's now into Minecraft. But the role-playing games have always been really popular and these massive online role-playing games. And I think that one of the things in architecture school, we sort of have the reverse problem. We've got too many students, so you guys might have too few, but it's managing students in terms of more and more group projects in order to manage the works. where students would really prefer to work alone, but I'm sorry, you're working in a group of 4 because I only have time to grade so many projects. And the problem with group projects and group project dynamics has always been that we've got 4 architects working together, butting heads on a project saying, it's my design, it's my design. And I think role-playing is another way to bring in engineering. And you can start to mimic, if you can't actually have the relationship with the organization outside the school where you are, you just can't manage that. If we start to bring role-playing in to design, where everybody takes a turn being the architect, the engineer, the site planner, the public official, the client, then we can begin to sort of, maybe in a way that students these days grow up with video games and role-playing games, can begin to engage on that level and sort of dispense with, I'm not the star architect on this, I'm going to drive down, I'm going to win my points against this boss, and I'm going to get this other thing going. And I think it might be one sort of an innovative way to begin to make somebody champion the technology in the project and begin to understand different viewpoints, which I think is part of, what we need to understand in broad terms within our whole education. How do we appreciate somebody else's viewpoint and take it on as our own viewpoint?
Yeah. There was a question here. I'm just going to make a comment relative to the observation about Gropius's writing. Notwithstanding everything that has been said, or what you think about Gropius, about 60 years ago, there were 2 gentlemen who, one was an architect, one was an engineer, and they both were literally saying and writing exactly the same thing, because in each of their disciplines, they found that the only way that they could really foresee the next kind of wave of development of the project, which was how do we create incredible architectural spaces, was to actually do it collaboratively. And one wrote extensively and just couldn't keep quiet about it from an architecture perspective, and one wrote about it from an engineering perspective. And one was Gropius and the other was Ove Arup. And so the fact that Arup has basically cornered every single global capacity that's there on the market to deliver and to procure services is because Ove Arup bred it into the way the organization is structured. You collaborate, you bring in data, you understand how to work, you bring in people, you talk, you converse. I mean, that in that conversation, it's Arup who's now considered the kind of signature to that success is unfortunate, since these gentlemen were having these conversations, I'm not sure together, but at least in the same time. Just to respect the request for questions, I will absolutely in a second, and then this question.
Well, just saying specifically to your point, the map that, Jonathan, that you were showing about the interconnectedness of the engineers in London, I'm deeply familiar with that because I went to graduate school there, but it's actually a process of mentorship. The ideas that you are intended to work at Arup, and then the ideas that you distribute, right? So that you keep the engineers and architects moving around such that there's a culture of discussion about the relationship between those things, that they're not divided silos in any sort of way, which speaks to what I was originally going to say, which is that at my regional caucus discussion this morning, we were talking about how ACSA might begin to take on a better role in defining what architectural education is for prospective students, whether they be high school students or even career change students. I think in some ways some of our older students, and I don't mean that they're really career change, but maybe they started in another major and have changed, so they're 20 years old as opposed to 18. There's a very different mindset, but we have a lot of students that come to IIT thinking that architecture is only building technology, It's really about putting physical things together. So we have the kind of other direction, where we're trying to turn them into pragmatists and poets in some way, but and I think that it's because there just isn't a kind of public discourse about what it means to be an architect, but more importantly, what it means to study architecture. And I wonder if the conversation about building technology is being more than just how do you put buildings together or how do you learn the tools of being able to design them, but to think of it as an integrated system. But I think we have to be advocates for what that means. We just do not have in the United States a public discourse, or in North America, about what it means to be an architect, right? Everybody's got a different definition, but we're not having that conversation publicly. So I think actually, speaking of Latin America, that we have a system in North America that's about protecting from the worst, right? So it takes you years to be able to practice, as opposed to, our southern neighbors who think, let's provide for the best, right? So the critical pressure, the risk is that you're not going to put yourself out there unless you really can do it. So it trickles that pressure down to the education, and that you're not sitting in a mech-elect class thinking, I'm never going to have to pay attention to this anyway or know it, because I'm just going to hire some kind of engineer because that's our legal or procurement structure.
Isn't it also regulatory capture though, where the AIA all these years ago
There's so many
like
things.
blocked access to practice by setting these extremely high accreditation and licensure bars?
Which is a kind, yeah, fine, it's a litigious protection system. But I think it will keep worsening unless we advocate for the fact that our students are actually quite knowledgeable about the physicality and the capability of even complex systems and buildings to operate. But more critically, they care to learn it in such a way that it's integrated into the design work, because there is some kind of critical pressure to do that. So the risk is important, right? The risk actually forces the issue. I feel like BTES, ACSA could actually be making that argument much more publicly.
I had a comment. You brought up O'Brien, and I stumbled upon his design philosophies just recently, and I really enjoyed his description of team. And I'll use the word team instead of group, because I find, having returned to school recently and been forced to work through group things, because that's what happens in the real world, I appreciated O'Hara's description that a team functions best when the members understand the other person's specialty and respects them for what they're bringing to the table. And I've found instructors, and although I might have done this once or twice as I was teaching also, I've been in situations where 4 students are put together and the answer is, well, they're not working together because they all want to be architects. Well, they're not working together because they don't understand each other's strengths and they weren't given roles and descriptions. I don't think, and I would argue that I don't think role playing and subjecting somebody to do something that's outside of what their strength is going to be is as beneficial as maybe doing vertical studio analysis, where there's a 2nd, 3rd, and 4th year student that is there. Each one has a specific role for the project, and so they understand what they're doing, but they get to witness what happens at these higher levels. Is maybe a way of integrating this group understanding and teamwork within a project, so they can appreciate and understand what somebody's bringing to it, but maybe not forced to, quote, compromise through design and group. So I'd like to.
Yes, Julian. Just to hear from someone, and then we'll come back. We'll get to Rashida to join us.
Just related to some of these kind of prompts, I think it's pretty amazing to think about some of the gaming or even the kind of creative architecture machines. There's sort of an element of play and this desire to see something built that allows, I would think, all different types of students to engage in a kind of technical dialogue because they're interested in it, and it's not being forced upon them, but it's kind of, there's an outcome that's exciting. And I think that's maybe one of the keys to collaboration, that when you have a genuine interest in what the partner can bring to the table, enough of a confidence that you can engage in that technical dialogue and get what that consultant can kind of offer you and work together, that's when those collaborations are successful. And so it's interesting to think about what effect it would have if that was used as a mechanism to broaden the understanding of what architecture is. They recently celebrated the centennial anniversary of the Burnham Plan in Chicago, and one thing that I didn't realize until that celebration was that the Burnham Plan was forced as part of the pedagogy in elementary schools. That's how it became embedded into the public consciousness in Chicago, that all elementary school students had to learn the Burnham Plan. So it became, those people grew up thinking, well, that's what Chicago is going to be. And so, relative to this understanding of STEM and do we have the time or do we need to make the time to introduce what we do at a different level before people go off and become these collaborators that we're so interested in kind of knowing this is what architecture can be. I think some of those mechanisms might be the key to that introduction.
Very good, Rashida and Julian.
I just had a comment about the idea that we
don't educate the public really about what it means to study architecture and what skills we're looking for that high schools might give students before they apply, maybe to encourage them to apply. And I was just reflecting, and Jonathan, you brought this up in your talk last night, this idea, this kind of chronic problem that architecture has had maybe since the beginning of increasing the diversity of the profession. And really, with ACSA having a new initiative towards communication, I think that educating the public about the kind of breadth of the field, and really the fact that Minecraft is very much architectural, and it's very much thinking spatially, it's very much a kind of skill set that might indicate a propensity to study architecture and to do well in it and to enjoy it, is something that we haven't ever done, and it may begin to help us address some of these issues of broadening the group of students that can envision themselves one day becoming an architect.
Just to pick up on this point, I think, you know, what you were asking before, and I think part of this larger conversation is, in a certain way, how do we embrace being public intellectuals? You know, intellectuals in the best sense of the word, you know, perhaps society would have suggested, you know, long time ago. The effort of becoming an intellectual, you know, is somehow under attack. You know, so we think of practice totally devoid from sort of thinking process. And it's not the case. I mean, we just demonstrated that. We need to think about labor practices the same way as we need to think about joints. You know? I mean, we need to be concerned, let's say, about it. And the question of advocacy, I think, is absolutely critical. How do our larger institutions, like this one, you know, begin to help all of us reframe the relations that we establish with the public, and how we construct a new public, which is a question of relation to art. How does this relate to the question of public, you know, and politics that are kind of very much connected? I mean, I finished a couple of years ago a large project in France, and that included very complex technological issues. We had to build a dam underground, you know, to stop the water to come in. We had to construct very complex large pieces of glass, but all of that was done through all the time construction and collaboration. And what I mentioned about the delivery system, the same project designed in the United States, not the documents needed would have been this much. And what we did there, because of our collaborators and our partners, and we work with RFR, you know, the son of Peter Rice, and so the document system was this size, because many of the decisions were done on site. And what is important is that every single company bought into the kind of the delivery system that established that kind of process of teamwork and collaboration. And to me, there's two aspects that are important here. One is this public advocacy, the idea of becoming real public intellectuals. And the second one is to find a way to instill in our students that same sense of urgency we may have today. I very much appreciate what I saw, and it's very inspiring.
Thank you, Julian. And this is probably the worst part of this entire 1.5 hours, which is that I actually have to call it a close. Because I don't want you to be late for the business meeting, which probably started about 5 to 6 minutes ago. Thank you very, very much for participating. Thank you so much to our